We start with this right triangle. Let's label A, B, C and label the sides with lowercase letters A, B, and C. And also let's call this angle, C is a right angle. Let's say this angle B is theta in degrees, suppose. Then if this is right angle, the other two acute angles add up to 90 degrees as well. Then, so they are complementary. So A is going to be 90 minus theta. Now let's go ahead and try to write down cosine theta. You can use SOHCAHTOA. Cosine is adjacent over hypotenuse. So in this case, adjacent to theta is A, over hypotenuse is C. Now notice, if you try to find out sine of 90 minus theta degrees, then for sine you got to take the opposite over hypotenuse. Now opposite of 90 minus theta is A over C. So these two values are the same. And that's because whatever was adjacent to theta will be opposite to 90 minus theta, and they have the same denominator of hypotenuse. So we can write down this identity. Sine of 90 minus theta degrees equals cos theta. And you can also write down cos 90 minus theta is equal to sine theta. And in fact, cosine is short for complementary sine. So if I'm taking the complement of theta, complementary sine of theta, it should be cosine theta. And same thing. So wherever you see the prefix co, it means it's complementary. So where do you think cosecant and cotangent are coming from? And if you're saying secant and tangent, you're right. So let's write down tan of 90 minus theta is equal to cot theta, cot 90 minus theta. So tan and cotangent are complementary. Secant 90 minus theta is equal to cosecant theta, and cosecant 90 minus theta equals secant theta. Since I'm using degree measures, I have to write degree. But if I were using radians, then I would write sine pi over 2 minus theta equals cos theta, and so on. So these are the 6 cofunction identities. Sine, cosine, cosine, sine, tan, cotangent, cotangent, tangent, secant, cosecant, cosecant, and secant.